Matrices. Matrices are one of the building blocks of an entire field of algebra called linear algebra. Now, in this class, we just want to get introduced to matrices and see how they can help us streamline solving some systems of equations. But first, we need to know what matrices are. So, the singular of this is matrix, and the plural is matrices. Please note the spelling difference. Now, a matrix is simply a rectangular array of numbers. Not numbers in a triangle, not numbers in a circle, but numbers in a rectangle. Now, notice that if I just write 6 numbers on a piece of paper, there's no way to tell that that exactly is a matrix. So how we denote that something is a matrix is with these little brackets, and they're sort of extended because when you draw matrices, they'll take up maybe more than one line on your notebook paper. But they've got these little feet on them. So it's very important that you put your rectangular array of numbers in brackets with feet. Now, we have these numbers. They're shaped like a rectangle. Items can't be missing. There will be an entry in every spot. If you don't see something, it might be a 0. But each entry is called an element. And an element is just one of those numbers that's in a matrix. When we talk about dimension in a little bit, we'll talk about the size of this matrix. Now, matrices can get as big as you want. Think of an Excel spreadsheet. An Excel spreadsheet is like a really huge matrix that you put number entries in. And any sort of data can be presented as a matrix, and these can get really, really big. I'm talking thousands and thousands of rows and columns, and they can represent a lot of data, and they're used in social sciences, and they're used in physics, and you can look for patterns in the numbers, or you can use the numbers for other calculations. Matrices are really, really useful in mathematics. Alright, so let's take a look at matrix A here. Now when I read matrix A, I say that matrix A is 2, 4, 1, 5, 7, 3. Note that I read that off by rows with a pause at the end of each row. A capital letter is what denotes a matrix when we're talking about this. So we'll say like matrix A equals something and B equals something else, then I can talk about A and I can talk about B without listing off every entry in them. Now a matrix has dimensions. Think of the dimensions of a room. Rectangular room has dimensions. Rectangular matrix has dimensions too. But it's important that we look at them in a specific way so that we don't get confused. The dimensions of a matrix are the number of rows in the matrix by the number of columns in the matrix. Just like the dimensions of a really common board used in construction is a 2x4, we say that the dimensions of A, this matrix that I've written at the top here, is 2x3. And I say 2x3. That does not mean times. Notice that little by symbol, which looks like an X, is resting on the line. It's not up in the air like the multiplication symbol. And this means that this matrix has 2 rows, rows go side to side, and 3 columns. Columns go up and down. Think of columns in the Parthenon, and that will help you remember which is which. Now, each element in the matrix can also be located by its address. So maybe I just want to talk about the 3 in this matrix, but if I'm talking about a really big matrix, it's hard to guide you to that number by saying, oh, look to the bottom right, no, a little bit up. It's much easier if elements have addresses. So addresses work like this. If I see A21, that means I'm looking for row 2, column 1. So I go up to my matrix, and I look at row 2, and column 1, and 5 is the number that I see there, so 5 is the entry that I'm looking for. Its address is 2, 1 in this matrix. Alright, now that you know what a matrix is, it's time to learn how to add and subtract them.